Hey everyone, today I am back with one of the most important topic which is known as the class imbalance. Before starting with the problem of class imbalance, let's first revise the classification problem. In this type of problem, we have the various classes and categories. We need to predict these classes. Now, as a simple example, if in a village there are let's say 1000 animals and you are said that there are 998 cows and one is a dog and other is a cat. Now if I say that I can see an animal, what animal it can be? The answer would be the cow. The reason being, you have been trained that there are 998 out of 1000 animals are the cows. This is where we face the problem of class imbalance. For the cow, we say the probability of being a cow is 998 divided by 1000, but for the dog, it is 1 divided by 1000. But the probability is not zero. This means that the chances of being a cow is high, but for the classes which are less or which is said to be in minority will be low. This is how we can understand this very simple example of the class imbalance. Now, let us take a practical example. Let's say there is a class or a classroom where there are multiple people. There are a total of 10 people, and we say that 9 are students but 1 is a teacher. Now you are asked to classify these people as student or teachers. You can easily say that your data has a class imbalance problem. Reason being, 9 out of 10 is the majority class and 1 out of 10 is the minority class. If you do not handle this problem, the result will always be biased. Let's understand little bit in technical terms. There are two classes, one is the student, another is the teacher. The class student is 90% of the data set and the class teacher is just the 10%. But we are interested in identify the instances of the class teacher. We can reach an accuracy of 90% by simply predicting the class student every time, but this provides a useless classifier for your intended use case. Instead, a properly calibrated method may achieve a lower accuracy but would have a substantially high true positive rate, or which is called as recall. These scenarios often occur in the context of the detection, such as that of the abusive content online, disease marker in medical data, and many other scenarios. The most important assumption of this particular problem is that, as per our business, the techniques would not be useful if the business says that we have to just detect the majority class. Therefore, our goal is always to identify the minority class. Now let's understand the evaluation metrics that would come into picture. First starts with the definition. If I talk about recall, it is the percent of truly positive instances that were classified as such. Then is the precision. It is the percent of positive classifications that are truly positive. This problem deals with the trade off between the recall and the precision. In situations where we want to detect the instances of the minority class, we usually concern more so with the recall than with the precision. As the context of detection, it is usually more costly to miss a positive instance than to falsely label a negative instance. Then is the AUROC. It is the area under the ROC curve. An ROC curve shows the trade off between the true positive rate TPR and the false positive rate FPR across the different decision thresholds. Then is the F1 score, which is needed to actually seek a balance between the precision and the recall. Accuracy can be largely contributed by a large number of true negatives, which is most business circumstances. We do not focus on, whereas the false negative and the false positive usually has the business cost. Therefore, F1 score might be a better measure to use if we need to seek a balance between a precision and the recall and there is an uneven class distribution, that is, there is large number of actual negatives. Now let's see how do we solve this problem. The first method is the resampling. First one among the resampling is the natural resampling. The main goal of natural resampling is to collect more data of the minority class. It is simple to obtain, but it is not always possible. In dataset where the class imbalance problem is a part of its own nature, it's hard to collect a data as the majority class. Then comes the artificial resampling. Under this, we are having three techniques: undersampling, oversampling, and the smotting. Undersampling means it reduces the data of the majority class. Oversampling, it replicates the minority class. And third one is the most important, which is the SMOTE. It is the synthetic minority oversampling technique, which makes the synthetic data points by finding the nearest neighbors to each minority sample. This is mainly about the resampling method. Now let's move to the algorithmic method. In this, the various things are the cost sensitive learning method, one class classification, ensemble method. So, cost sensitive learning method, it assigns the misclassification cost into the learning algorithms. The main goal is to minimize the loss function and encourage the algorithm to favor the minority class. Then is the one class classification. It differs from the other classification method due to the change of classification target to one class target. It takes into account only one class, the new target, and ignores all the other classes, the outliers. Generally, this method is used to single out an error or unwanted objects, but also to deal with the imbalanced dataset. Last one is the ensemble. It combines the predictions of different classifiers. Mainly, there are two types. One is the bagging and other is the boosting. In bagging method, it trains all the classified with a different bootstrap of the dataset. A bootstrap is a random subset of n samples and they are replaced more times. Once the models are trained, the final output is the majority vote of the classifiers. Then is the boosting. Boosting uses the most difficult class to predict to train the classification model. The first classifier is trained with a random sample of dataset. The class that has more misclassified records will be the majority class in the next sample, and so on. Now, this is about the algorithmic methods. Now, the next method is the feature selection method. So now the various topics under the feature selection method is the metrics, wrappers, embedded, and the relief. So the curse of dimensionality tells us that if many of the features are noisy, the cost of using a classifier can be very high and the performance can be severely hindered. Because the class imbalance problem is commonly accompanied by the issue of the high dimensionality of the dataset, applying feature selection techniques is a necessary course of action. The goal of feature selection in general is to select the subset of J features that allows a classifier to reach an optimal performance where J is a user specified parameter. For high dimensional data sets, we use the filters that score each feature independently based on a rule. Feature selection is a key step of many machine learning algorithms, especially when the data has high number of features or highly dimensional. Then let us understand what is this matrix. Matrix, it ranks the features by own individual payoff to classify the records. Then comes the wrapper. It trains the learning model on the subset of the features. The model's performance is used to choose the most useful subset of the features. The feature subsets are trained more times. That could be a problem if the dataset has high number of features or large number of columns. Then is the embedded. It aims to choose the best subset of features inside the model. The recursive feature elimination algorithm in the SVM is one of the example. The last one is the relief. Relief is an algorithmic approach. It uses the nearest neighbor method to find the features for which their own instances stand out from the nearby points. So now, on a summary, we have mainly discussed about the ways we can solve the class imbalance problem. The first one is the resampling, second one is the algorithmic methods, and the last one is the feature selection methods. One of the most important thing that we have to take care is that we should know what metrics we are going on. It is not always the accuracy, but we have to focus on some other metrics like that of the AUC, F1, and other things. The choice of the right metrics is based on the target goal and the cost of misclassified records. We have to stress on the minority class. And the method outlined are principally three, that is the algorithmic method, the data pre-processing method, this is nothing but the resampling method, and the feature selection method. So now I have explained what is class imbalance problem and what are the various ways we can solve it. Any type of questions, please ping me on the chats. Any comments, how do I improve? Those are highly welcomed. Please like and share the video. Thank you. We'll come back with new important topic, important for data science beginners as well as for various type of interviews. Thank you.